Okay, so thanks. I think this is the final recap about the questions. So we selected 3 questions that we think that are interesting. First one is really the definition of serverless computing, and this is really controversial because not 2 people think the same. And in our group, when we read the paper from Samuel, I mean, we have people that were completely convinced about his definition and others that were opposing this definition completely. So, and it's difficult to reach consensus. Here we have the voting before Samuel explained the keynote. So maybe some people change their opinion. And maybe, I don't know, Alec, maybe what we should do is to let some proponents of the disagree say why they don't agree with this, and maybe it's less people because now some will convince them about the definition. So maybe some of you that voted I disagree can explain your position.
And please raise your hand so we can see that you want to ask the question or actually answer it. If you have any thoughts, please go ahead. I can start by saying I was disagreeing. I think those definitions change over time. If you look back in history, cloud was so great supposed to solve all the problems, and then I think we now, after 15 years or so of cloud, now we want sky computing or something else to come and provide you what was originally promised. So I don't think we will have ever one definition, or maybe we will have it after, few decades passed, and then there is no more developments in serverless. Then you will get a definitive definition.
Some volunteer. Marcin, what do you think about this definition? Sorry to attack you directly.
Yeah. Sorry, I couldn't hear exactly. So you're asking what I think about this definition?
Yeah. So I mean, when Samuel introduced this definition, what he's saying is put elasticity aside, because this is something that the provider should provide. So it's not part of the definition. And he explained in the keynote why he thinks it's like that. So I don't know if you voted I agree or I disagree, but I would like to hear what you think about this.
Right. I initially disagree. I'm still on the fence, so I'm not entirely convinced. I'm willing to agree on the autoscaling part. I think there can be aspects where the user might be able to or should actually have more input in terms to define what should be, for example, the scaling policy in that context. So for example, we already seen this, for example, with Lambda or Azure functions, that you can tell a little bit that you might want to have some active pre-warmed instances. This is some way of basically user providing input that I want to affect the scaling policies in a very specific manner. The elasticity, I would still think that this has to be the core part of the serverless. If we have a system that needs a very constant workload, a very constant allocation that doesn't need to change, I don't see that serverless is really an answer for that type of workload.
Okay, super.
Samuel, you have your hand raised, and then Joseph. Go ahead.
Yeah, I just want to make one comment I wanted to add to my explanation previous. So if we include elasticity, let's say as a kind of explicit kind of distinguishing property of serverless platforms, then my assumption should be that it's then possible to verify if a given platform fulfills the property or it does not fulfill, right? Under this assumption, you have the following problematic. Elasticity for what? Now, consider a complex cloud applications. Speaking of scaling resources, the questions arises, which resources? Virtual machines, containers, threads, database connections, physical servers, network capacity. There are all sorts of resources. So which are scaled? So speaking of the cloud has to scale up, immediately opens up a tons of questions, which particular resources are scaled, how accurate should they be scaled? How fine granular should they be scaled? What is the demand that we assume in terms of saying this is enough scale or less enough? So we open up a lot of tons of questions, and it becomes virtually impossible to judge, does the platform fulfill those questions or does it not fulfill those questions? Because it's just a matter of interpretation. I might scale one resource but not scale the others, and I call it elastic, right? Another platform scales all of them fine granularly. It also calls it elastic. So that's one of the reasons we think that the new things in serverless is not about elasticity as a property, because it has been a targeted thing and challenging all the way up until now since the beginning. It's about moving all of these concerns, technical concerns, offloading them to the provider, basically. That's the new thing. And the other thing is old thing. We saw it in the paper. So this is just a comment. Sorry for being a little bit long.
Joseph, you have your hand raised. We cannot hear you. You need to unmute yourself.
No.
Joseph, feel free to, if you can hear us, feel free to unmute and then ask your.
Joseph says, I cannot unmute.
Okay. Interesting. That's a challenge. I will make you co-host, so then maybe you can control your destiny. I have no idea. Can you try now? If not, try to reconnect. Sometimes maybe Zoom left you like your audio device not working.
In the meantime, I could say something about this statement, if that's all right. Yeah. So I voted for the I agree one on this because in my so from my work on serverless, the way I've interpreted it mostly is that it's one of the key things is this idea of full automation and pay for what you use. And so I don't really care if it has state or not, or if even what the cloud provider needs to do, I guess. But if the application responds to the workload without the, it becomes difficult. Who is the user? But if we can make systems and deploy them to the cloud without requiring, let's say, a team to do operations on it, because the cloud provider somehow manages this, then in my mind, it's serverless. So this goes a bit along the same lines as what Samuel said during the keynote, that if you have enough resources, maybe you don't scale up or down, you just over provision, but still it's all automatically managed. So I think that's, at least in my mind, a more fundamental property. And the second reason why I agreed was that it may not set it apart enough from existing cloud computing. So we already have some of these features. I guess it's so expected to have elasticity that it may not even be necessary anymore to have it in the definition.
Well, what I think here is that either it's included in the definition or it's a requirement. Because I mean, if I have to scale to 0, I need elasticity. How the provider is offering me that, I don't know. Maybe he's over provisioning or whatever, but he needs to give me elasticity. So if scale to 0 is part of the definition, then either elasticity is a requirement or it should be in the definition, no?
Well, I guess it's only useful for the cloud operator, right? If you just pay 0 but they don't scale to, if you pay nothing but they don't scale down, then they are running VMs and they pay for it. So
I mean, this is also what we have seen with some of the new serverless databases on AWS, that they don't scale to 0. I think Aurora is one example. It's much easier for them in terms of implementing the scheduling, but you as a user end up with the bill, and it's actually not even the lowest traffic it has to support is actually not that little amount of money per month.
Maybe a brief comment on scale to zero. Again, an interpretation. Scaling what to zero? If I keep some containers ready, or some virtual machines maybe in some kind of sleep, whatever mode, is this now scale to zero? Is it not scale to zero? What does zero mean? Basically deleting complete knowledge of this application, because there are many, many resources you could consider, virtual, like physical, right? And then the second thing is that most providers would probably not want to scale completely to zero, because if they're expected now to provide your service level agreements at any point and some unexpected load might appear any time, they might have problem with code starts and such things. So they might not want to scale completely to zero just to fulfill your service level agreement, right? To be able to scale up quickly enough. Otherwise, if they're completely downscale, they might have problems. So they're efficient, right? But they pay penalties for not fulfilling your service level agreement. So they might save money in not wasting resources, right? By shutting them down, but then pay you a penalty because your service level agreement was broken, which might be much more expensive. So in this also scale to zero, it's a subject of interpretation, how much we interpret on it, right?
Yeah, and scale to zero, I mean, it's two views: view from the user experience, or view from the infrastructure. So from the user, scale to zero is you are no longer billing me. So I'm not using functions, you are not billing me. But it could happen, like you say, that even if you are not billing me, you still have the servers there for other users. And then scaling to zero for the provider, it's that he's maintaining the infrastructure. But normally you always see the user view, not the infrastructure view.
Yes.
For this. So scale to zero, normally you associate to the user, and maybe it's what you want to provide in your definition. Separate the view from the user from the infrastructure view.
Yes, we call it utilization-based billing, basically, which is exactly this aspect. If the utilization is zero, which means my code is not running, it does not need resources, you charge me zero. So this is in a way. But most of the people speaking of scale to zero, they also interpret scaling down the infrastructure to zero, like elastically. Not from the user perspective, more like from the provider, if you look at the definitions that speak about it.
That's super interesting. It's a controversy. Maybe we don't arrive like a quorum or something like that. I don't know if Alec or some more people want to say something before we pass to the next question.
We have Sashko and then Marcin.
Okay, let's go for that.
Yeah, my point was similar, like Pedro, you mentioned that we should split elasticity from the user perspective and from the provider perspective. And we should define elasticity of what? I would add elasticity and auto-scaling of which service? Of some serverless service. For FAS, it is the function. For virtual machine, it is the virtual machine. So if I ask the cloud, I need to run 3 instances of my function, this is my service. And how fast I get those that service. If I ask start 3 virtual machine, how fast I get those 3 virtual machines. If I use or not, it's another question. So I would define what is the service that is required and that is elastic, not the resource. The resource in serverless, we don't see them, and because that is the remaining part of the definition is that the full management is on the provider side. What Samuel mentioned from ChatGPT at the end, this the last word. So if we offload the management, then we don't see those resources in the cloud. But when I deploy my function, my code, I see my code, I see the function. So how fast the function will be started. I mentioned another question on the Discord. The other problem is whether they really give us the resources that they promise. But I agree with you, Pedro, that yes, that is a SLA problem, not not the elasticity problem. I agree. So I would say in this I disagree. I agree. I think that elasticity should be mentioned in the definition as a cloud service, as on top of the cloud, but we need to define what is the service that is elastic in this case? Is it the function? Is it the serverless database, or maybe backend as a service, as I presented yesterday? If I call, here is my image with 10 faces, return cropped faces, and that is my serverless service. And if I give you 10 images, I want elastically to have 10 instances of that service. So elasticity is needed in the definition, but to what extent, to which service is that elasticity? This is my view.
Marcin?
Yeah, so I wanted to say something similar to what Pedro already said. It's that in the end, I as a user should not be thinking about this. To me, scale to zero is really the property of the billing model. I pay for something very specific. I pay either for the compute time that my function is using. I'm paying for the request to the storage. I pay for the amount of data I put in the storage, or I pay for the amount of data moved over the network, one way or the other. I should not be, as a user, concerned with how many warm containers is the cloud provider operating. Are they keeping some, or are maybe doing what AWS is doing these days, so trying to do a little bit of prediction and warming up containers before my invocations arrive? If I have to now start thinking about this in terms of definition of my program model, I think we are starting to break this promise of abstraction. In the end, I think that this would be a property of the way how user views it. Of course, from the cloud provider perspective, it's a completely different story.
Yeah, cool. So I think to close this question, maybe, I mean, because we have here two of the main authors of papers defining serverless, because I mean, one is Samuel, but the other is Alec. So Alec has this paper on the rise of serverless computing. So maybe we can conclude with Alec comments and then we move to the next question. Alec, what do you think? Sorry to put you in this position.
So when we were writing it, I don't know, a few years ago, that one part that we realized very quickly was that original definition of the cloud, as Samuel described also in his keynote, sounds very similar to serverless computing. It's like the goals is like self-service, and you pay as you go. Users decide what infrastructure they want exactly and then run it. Just turned out this is not what actually users really want. Nobody really wants to assemble infrastructure and then scale it up. And I think that second part, scaling, is actually way more difficult than just get something running. Like you had in Amazon, all those virtual machine scaling groups, auto scaling groups, and so on. And you had to set policies, when to scale it, and so on. And then you end up with the big bill at the end of the month because you know auto scaling policy was too good and it was scaling too fast or whatever. That, I think, is the actual value of serverless computing. That part that you pay, not just as you go for the infrastructure that you allocate, but you pay for the infrastructure that you actually use, and it is scaling with you as you are using it more. I agree, probably most of users do not care too much if it is, you know, exactly elastic or whatever is going behind the scene, but I think they really care that they get that service SLAs, and they have that capacity, hopefully big enough for their needs. It's not unlimited. Most of the cloud providers will put a limit, and you actually have to ask, even though, you know, they are saying like, hey, this is scaling and whatnot. If you try to scale too much, you will quickly discover there are actually limits in your cloud account. So nothing is for free. Everything has limits. But if you can make it easier to use, I think that's a reason people really like serverless as compared to cloud computing.
Okay. Maybe, I don't know, Samuel, do you want to say something final on this, or we move to the next question?
Yeah, maybe just one final statement. I completely agree. There are different viewpoints, as we saw in the discussion. You know, Marcin and I think Sashko also went in this direction. one could, of course, look at elasticity and scale to zero from the perspective of the user. And this changes the game, of course. Looking from the perspective of the user, then it makes sense to speak of, even elasticity in the definition. However, if you look at the classical literature the last 15 years, you would notice that elasticity, the way it is used, it's almost always directly or indirectly related to resource scaling and auto-scaling, which includes the provider part. And that's why our kind of interpretation of elasticity is indirectly or directly linked to the resource scaling on the provider side. And that's why we wanted to avoid this. By the way, and just to finally to close it, we do have elasticity in the definition. So if you read, the second sentence, the responsibility for operational aspects such as fault tolerance and elastic scaling, right? It is in the definition, but it's like included like an example of a technical thing that has a lot of different scopes and interpretations and fine granular versus not fine granular implementations and whatever, and not as a kind of, okay, this is exactly the new thing, because if we put this as a kind of, this is the new thing, then we have to tackle the question of literature speaking about it for tens of years before that, right? Anyway, I think that's enough for now. Thank you very much for a very interesting discussion. There is no good or best or whatever definition. We have different viewpoints, and that's nice that we have nice discussions. I enjoyed it very much. Thank you very much.
Nice for your concluding remarks. So it's cool that we can really talk about this is philosophy. I mean, we are defining serverless, so it's ontology almost. So then the second question here, this is more speculative, and this is more speculative because many people are humble and say, I don't know, no idea. So here, this is a myth or it's real. So some people say that, serverless, like public cloud providers, need to over provision. Even when you are doing warming, you are like using more resources. And then it's interesting, when I was in Eurosys in this other serverless workshop, these guys, that it's one of the chairs, they quantified the tax of the system tax in serverless clouds. Well, I don't believe in their numbers, I must say, because they really said, okay, it's 30% of compute over provisioning and 70% of memory, I remember in their paper. And I said, how you calculate that? And they said, I tried some workloads in Knative. So maybe this is not what Amazon is getting in their data center. I mean, what we can do, academics, is really speculating about what they are doing inside. So maybe this is only speculative. Other papers, like towards sustainable serverless computing, this is more energy focused. But what they are saying is really, whether you are warming resources and when you really need to provide all these resources, you are wasting energy. And it's not like that, like when you launch a virtual machine and takes minutes. If I have to respond in hundreds of milliseconds, maybe I need some over provisioning or some running code. So it's really expensive to maintain these services. And here, even in this paper, the sustainable computing, that is one of the topics that we raised, like interesting for serverless today. They even say that users should help the cloud provider with hints, like telling, hey, at that time I will need that many resources, and then I could be prepared for that. And then it shouldn't be like I received a spike and I have all these warm instances, but the user is helping me to optimize things. I don't know, maybe this is all speculation. Maybe our answer should be no idea. But I would like to hear some proponents of, well, there is only one no, and there are 6 yes and 7 no ideas. Can anyone from the yes, no, or no idea raise hand and say their opinion about this question? Volunteers?
I mean, I answered no idea because of what you said. I'm guessing what's happening inside AWS. I really don't know. Well, first off, I don't know what they're doing exactly, but also perhaps more interesting, I don't know how much or if any over provisioning is required, right? So the required over provisioning itself, I think, is a question mark that could differ for different application types. So there were just too many unknowns, I think, for me. But it's an interesting question to try to answer. What would we need?
Okay.
Yeah.
Then it's good because there are you are the majority. The people that say I don't know, that it's a good answer. I mean, it's I cannot. I from my side, I think that I would say yes because I think it must be expensive. I mean, you need resources prepared for people there. If not, you cannot offer this kind of service. So offering, and even Lambda, because others are not that good as Lambda. But if you are Lambda and you are responding that fast, you need either you are very efficient or you have like some over provisioning. And of course, if you have a lot of utilization, maybe you can pay off these costs. If you don't have a lot of users, but you must have this response, then maybe you are wasting money that you are not using. But this is, of course, I understand it's a speculation. So the guy that said no can defend his position.
Marcin, you have your hand raised?
Right, I also marked I don't know because similarly to Jesse, I have no idea what is the cost, and I think it also differs significantly between cloud providers. So what I've been able to gather based talking with the people, like the type of hardware or the provisioning that you use differs, for example, significantly between Azure and AWS. What I find interesting here is that we kind of trying to fit completely different classes of workloads to a single concept. So yes, there is always some over-provisioning that is required, but in the sense, it really differs heavily depending on the application. So some of them cannot tolerate specific spikes of latency, so they would need a different SLA, which of course will be more expensive. We have already seen this with Azure, which I think has 3 different consumption plans, depending on the type, and for some of them are more expensive, but they give you, for example, lower frequency of cold start. So it is a pure speculation, but I think it's maybe something model to which we migrate, because in the end, if we had to deploy ourselves the service to containers or to virtual machines, we would have to decide the degree of provisioning to make sure our application scales. I don't see a reason why this could not be a configuration factor for serverless.
Yeah, and it's interesting because I mean, if now it's a black box, but if we could provide them more information, like about our workload or about what we need, they could schedule more efficiently and do intelligent things with the schedule. If they don't know nothing about what they are going to receive, and there are many heterogeneous workloads, things get more complex for the provider. Yeah, that's a good point, Marcin. Alec, you are really an industrial guy from IBM. I imagine that you cannot tell your secrets, but
No, but I can tell you the theory behind, which is that you really want a lot of workloads and users, because you cannot predict any particular user, what they are going to do, but you are looking on the whole large numbers. That's what you really want. So you can predict to some degree based on that historical data, because behavior in aggregate is much easier to predict than asking, like, I don't know what's going to happen tomorrow. Maybe my service suddenly will become very popular, or suddenly nobody will be using it, right? Both things can happen. Nobody wants to commit spending. That's the reality. And like, I think serverless, it's one part of it, but what's going on with AI, that is they know they want more computing, and they will spend money to build it and keep running, at least for now, as much as possible. So there is no over provisioning right now because you cannot get enough GPUs and whatever. So different story, but we see how it goes in future. Where is the balance between demand, over provisioning, and then making actually money out, like being profitable. So you do not over provision, and then you have extra capacity that nobody is using. So yeah.
Here, what I think also is serverless orchestration. For example, when you have Amazon state functions, and you can give the provider like the order and how your pipeline is working, then it's not a black box for them. Then when you are giving really how your application is going to behave, then they can optimize and they can do intelligent things. So this black box, white box model, I mean, you have the provider has more information with an orchestrator that you are giving to them. So they should really try to give incentives to users to provide some information about their application, because that way they could really optimize how they use resources. Sometimes it's impossible, like you said, Alec, because if you have AI.
But what you describe is exactly what was, and I think it still makes sense, economical model for microservices or function as a service. You try to make it as small as possible, that microservice or function, so it can scale independently from all other microservices. So you're only paying for that function when it is actually used, and you do not need to worry about that some other parts of the applications are very inefficient or take long to start, or all those other problems, take too much memory and whatnot. You are scaling it, they run exactly with resources they need. I don't think it is easy to build applications like that, but that's the whole idea from you as somebody who's building that application. You do not need them to provide, prediction about use of the whole application. You can see how each independent small microservice is behaving and then optimize that part.
Yeah, of course, with the stateless small functions and disaggregated resources, it's easier to move up, and yeah, you don't need predictions. Nice. Some concluding remarks, some comments? Samuel, Jesse, the ones that I see in my screen now.
Thank you very much. It was very, very interesting discussion. I enjoyed it very much. And thank you very much to everyone asking questions.
Okay, so we go to the, no, Jesse wants to say something. Yes, go ahead.
I did a thumbs up for Samuel's thanks.
So we are finishing, so we should go for the last one. And here maybe we finish soon, because here is just science fiction or pure speculation. So this is like a wish list. It's what novel service would you like to see in the next years? And it's funny that we see sky computing and stateful fast as like the winners here. And also I see serverless ready, transparency, standards, communication APIs. I don't know, it would be nice to see all the service. One of the guys that said stateful fast, would you like to define your ideal service that would like to use in the next year? No? So, okay, Samuel.
In fact, I was one of the people who said this. Basically, we now speak of, in the context of the discussion, also of, requiring some service, and we speak of, virtual machine or function or something else. But in reality, what we want for the future is, I want to develop a cloud application, which might need a lot of different things. Virtual machines, it might need functions, it might need databases, it might need messaging infrastructure, whatever. And I want a programming model which allows me to program this application without having to care about resources, allocation, scaling, all these details, basically abstractly programming. And right now we're very limited, right? Fast is very, very primitive model, right? So how do you build a big application? So stateful fast would be one step in this direction. You build bigger functions with state, and you don't have to care about managing this state, for example.
Yeah. Yeah, it would be super nice to have this service. I agree with that. Jesse?
Yeah, so I was wondering about this statement, because if you say, I don't want to care about the scaling, how does that go together with more complex applications? Because then you need to, you still need to define or understand in what dimension scaling should happen, right? This is the whole thing that fast solves, it's stateless. So scaling equals replicating the thing that you have. But if you want to scale something automatically that has state, that does more interesting stuff, then you somehow still need to inform, okay, how does scaling work? Not how to take care of it, but what would be.
And this is exactly the reason we don't start the discussion, because as you see, it gets complicated here, right? It shows.
Yeah.
And that's why we don't start the discussion. We don't open this whole tons of questions. And the reason is actually the customer only cares about one thing. I give you, for example, the function or whatever, and I define to you how quickly it should run when accessed over the network. How many copies you have, if you replicate it, if you don't replicate it, if you use threading, if you use whatever, this is, I don't care about it. Scale it up, down, whatever. But when I call it over the network, it should respond within this amount of time. This is the abstraction from the customer perspective. And that's why I think service level agreements are another area, by the way, which I think should be researched further in serverless computing, how to define exactly this service level agreement from the perspective of the customers, right? Without having to speak about servers, resources, and all sorts of other technical things. From the perspective of the customer, what is a service level agreement abstraction?
Well, it's not just that it is. I think most of provider has service level agreements, but then what happens if that service level agreement cannot be met? And I think a lot of times just you get some credit back on your, what you are paying, but that's not what a lot of times customers want. I mean, it does not help you that your application did not scale and you are now like, your service level agreement is broken, but what are you going to do about it? Your business is going down because your customers cannot access it.
Switch platform provider.
I think all of them have SLAs. But look on not SLA, like what it promises, but what happens when SLA is not delivered.
I agree.
Then maybe also Sky Computing. If Sasco is over here, I'm sure that he voted for that. Sasco, your idea of Sky Computing?
Yes, I'm here, but I didn't answer this. I had lectures until 3:15. I joined later. But what I agree, in my opinion, I would vote for Sky Computing. That's true. My idea is to, I like this approach, and to be honest, we are also working in this area. What Samuel mentioned, that I need thousands of tasks. This is my problem size, and solve it. And I don't want to take care whether it will run on Google or on Amazon. I would even extend this, not only on one provider, but maybe on 10 providers or 3 providers that offer me the same service. So my view is to see what the customer needs, and if I need some service, I want to code my application that it requires this service, or I call this intent. That my intent is that I want to split some image or to convert some text into audio or vice versa. And then if it runs on Google or on Amazon, or if I code it myself, I don't care. At the high level of abstraction, this is my application. And then some middleware, some runtime system in the background should allow me, or that would be the Sky Computing, in my opinion, should find or should recommend me, or even it can be invisible to me, no problem. But it should decide where and how this request or this intent will be executed. And I would like to send my request and then to get back the result. What is in the background as a user, I don't care. This is my vision for Sky Computing. Yeah.
Yeah, and it would be like utility computing. I mean, if we could avoid vendor locking and
Yes.
use any provider like electricity or water, like you can use anyone. But I think that they are fighting on the contrary for vendor locking, and they are even in Kubernetes. the container platforms in the different clouds are very different. So we don't have really standards across clouds. So you would need like an additional layer, other provider that is creating this layer on top of them.
In my view, Kubernetes is one layer below, because that is IT. My vision is that the end users would need access to what is inside the container, not the container itself, because that is the service. The container is just the resource. The service is what the application runs inside the container. And my point is that if we have a service inside the container on Amazon or on Google, the code inside the container or Google will be different. And of course, also different cost will be for that. And Sky Computing should find the service that I need. I don't want to see containers as an end user. I don't know, if I am some doctor, I don't want to see the cloud services, but I want to see, I don't know, I'm speaking and then I want to record myself and propose something automatically for the diagnose, to diagnose the patient. This is the service that the doctor needs. And that service can be offered by 10 providers in Sky Computing, not necessarily cloud providers, could be some atop of the cloud, some provider which provides, which offers service for the doctor. And then that provider will use cloud services for scaling, whatever. I would say we should split the way like Netflix, for example. Netflix provides content to the end users, but Netflix uses cloud. So the end user wants to click and watch movie, and the end user doesn't need to take care whether the movie is stored in Vienna or in US or 10 copies and so on, like someone mentioned. Yeah.
Yep.
I think we should target that.
Yeah.
I just want to bring up, actually know some people working in Netflix. They are working pretty hard. And I think Netflix is now over 10 years old or something. And I don't think they are lacking as far as work goes. It's not like you can solve those issues and then you will create that amazing service cloud to run everything everywhere anytime for reasonable cost and with SLAs and so on. Army of people is behind all that serverless servers that keep it running, optimizing, analyzing, trying different things, building solutions and so on. And I don't see any time that army to disappear. Not just programmers. You know, people that are maintaining those data centers and building them and the whole electricity grid and all that, it's all connected. Those, I don't see any time we will have some kind of solution that will work for everything. Actually, we have only one really great system in, I think, in computing. It's called internet. You know, you are not rebooting internet anytime soon. We keep upgrading it all the time. And it's never down. That is a great example. And it somehow that worked out the cost economics and so on. People complain all the time that, you know, internet, like during pandemic, that the internet will go down because people will be watching Netflix so much that, you know, the bandwidth network will not be able to keep up. And somehow we, you know, upgraded it and you maybe watched with lower quality for a few months. That did not happen on its own, right? It happened because people are around. We are important part of all that computing serverless services. I mean humans.
Yeah, well, in any case, the utility computing, I mean, idea is not bad. I mean, all providers are offering like S3 compatible APIs. All of them are offering how to start VMs. All of them are offering like container services, like on top of Kubernetes, function as a service. You could standardize on that in reality, and it's not that difficult, but they don't want, and this could be feasible.
I think at some point there will be standardization, but it takes time, right? It must to become really utility, commodity, and economical model supports it. So and the value is somewhere else, but that takes very long time. Like electric grid is great example. It was not designed from the beginning to be utility. It took long time to build, and then how it is operated and so on. I think the same will happen here. It just takes time, and monopolies and whatnot will exist, and lack of standards will exist for a long time until you find better economic models to standardize and share and transparency and all that.
Okay, so maybe Alec, we should be finishing because it was a nice workshop, and I think it was super nice contributions. But maybe we will share all of this by Twitter and in the website. All the presentations will be there. But we should be finishing, or I don't know, Alec. What do you think?
I would leave it for the last questions if anybody wants to raise anything. But yes, I would say we thank you everybody who joined for that workshop. Especially thank you to our presenters. We will, I mean, we are recording right now. I will, upload to the YouTube and send email, and also put it into Discord when it is available. And hopefully see you again in future, right?
Yeah, thanks. Sure, see each other.
Thank you very much. See you.
Thank you. See you.
See you.
Bye-bye.
Bye bye.
Bye-bye.